scholars here, those of us who are watching, to try and translate these following expressions into algebraic expressions. And so what these are is they use variables. So anything you have, you want to make sure they have variables in it. And that's basically what an algebraic expression is. So for example, we're going to start with 2 times a number. Since we don't know what this number is, we can use our variable x. And if we're going to be multiplying that by 2, then we want to have 2 times x. But in algebra, we don't necessarily have to write this multiplication sign, so we kind of just leave it as 2x. If there's nothing there, we assume that it's multiplication. So this is how we would translate 2 times a number into our algebraic expression. And I like to draw these 2 lines just to indicate that that is our final answer. If we move on to the second part of our warm-up, it's going to ask you guys to write for more than a number. So again, we don't know what this number is, so we're going to make that an x. And for more than, when you hear the word more, we want this to be a specific operation, which is addition. And it's going to be for more than that number, so our final expression is going to be x plus 4. Whatever x is, we want 4 more than that, and that will be our final answer. And our last problem is asking for more than 2 times a number. So it's like you're going to combine this problem with this problem. You want 4 more than 2 times a number. So we're going to take that 2x instead of just writing x. So because it's 4 more than 2 times a number, we want to make sure it's 4 more than 2x, which is 4 plus 2x. And going into standard form, we're actually going to write that as 2x plus 4. And that's going to be our final answer. And once we actually go over what standard form means, you guys are actually going to see why I switched it from 4 plus 2x into 2x plus 4. So let's discuss, what is standard form? Well, standard form is basically a polynomial whose terms are placed in order. So it depends on the order that you place those terms, from your highest exponent to the lowest exponent. So we notice here in problem number 3 that this term 4 had no exponent at all, and so that's why you placed it last. And here the exponent, there's an invisible 1, so we put that one first, and this one had no exponent at all. So if we take a look at this example, how do we put 3x plus 8 plus 7x cubed into standard form? Well, let's take a look at our exponents. When there's no exponent written, we can assume that's a 1. This exponent has 3. And then this one has no exponent at all. 8 has no exponent at all. So we're going to start with the exponent here. 1. This one will go first. This one will go second. And we'll put this term last. And that's how we want to order it. So we'll first put the 7x cubed, then the 3x, and then the 8. So this is how our polynomial is now placed into standard form. So let's just check. Let's check for some understanding. What if Steve told Nicholas, so we're here, what if Steve told Nicholas that the polynomial 6x plus 3x squared was written in standard form because the highest coefficient is 6? Is Steve correct? If not, explain and correct his error. So let's go back to the definition. Should it be the highest coefficient or the highest exponent? In this case, Steve is actually incorrect. Steve is incorrect. We actually want the highest exponent. We want the highest exponent first, and not the highest coefficient. right? So, not too bad. Let's keep going. What else is there to learn? Oh, well, if we actually go back, we know that we are evaluating. We should be evaluating these expressions. So we want something that is equal to the expression and putting our final answer into standard form. So we see here, evaluating, we could be subtracting. We can also multiply. So when we are subtracting, one thing to keep in mind is the criteria for subtraction. And here, you guys can see here, this is where the criteria is listed. So let's go based off of those steps. First thing is asking us to distribute the negative to all terms, right? So what's happening is we're taking our first expression and we're subtracting from that the second expression, which means we have to subtract the 5x, we have to subtract the 10y, and we also have to subtract the negative 3. So what happens? We start with our 3x, this is what we have, plus the 6y, plus 2. And we're going to subtract off each of those terms. We're going to subtract off the 5x, we're going to subtract off the 10y, and we're also going to be subtracting, remember, we're subtracting a negative 3. A negative minus a negative, remember guys, that becomes a positive. So this is actually going to be plus 3 since we're subtracting the negative. All right, our first step is done. We distributed our negative, and now we're actually going to go ahead and combine like terms. So let's see. How do we know which terms are like terms? Well, they have the same variable and the same exponent. So the 3x will combine with the minus 5x. And what is 3x minus 5x? That's going to give us, since the 5 is larger than the 3 and we're subtracting, we're actually going to end up with negative 2x. And let us keep going. All right. Let's now subtract the 6y and the negative 10y. And since the 10 is greater than the 6, we're also going to end up with a negative 4y. And last, we can combine the 2 with the 3. And here we're just basically adding 2 and another 3, which gives us a positive 5. Now, this will be our final answer. Did we put this into standard form? Did we put this into standard form? And the answer is yes. And that's because they have different variables, and each of these have an exponent of 1 and 1. Those are invisible ones. So how do we know which one goes first? How do we know if the x term goes first or the y term goes first? Well, that's pretty simple. We just go in alphabetical order. All right, not too bad, not too bad. Let's just go back and review. What did we go over? Well, we took a look at just translating things. First, we took a look at translating things into expressions. So what if we have words and we need to translate that into an expression? Great. And then we went over what standard form actually means. And we used that to check and see if Steve was correct. And we realized that the focus with standard form is the exponent. It's the exponents, not the coefficients. So we be careful with that. All right. And we tried combining two terms with subtraction. And we got our final answer, realizing that because they're different variables, we have to put that in alphabetical order. Are we ready to keep going? Let's see. All right. So multiplying, and in parentheses, it says the box method. What exactly is the box method? Well, let's take a look at, of course, the criteria. So it says set up the boxes according to the number of terms. Now, what does that mean? Well, this expression has 2 terms. And this also has 2 terms. So what are we going to do? We're going to create a box. We're going to create a 2 by 2 box. Let us do that. multiplying is pretty cool. I love setting up the box method. And with this, we're actually going to line up, right? The first polynomial will go, it can either go on the top or the side. But I'm just going to put it at the top, and each term will correspond with each box. And then we're going to take the second polynomial that we're multiplying and line that up on the side. And now we are basically going to, we're basically going to multiply. Like a multiplication table. All right. So first, in our first box, and actually I'm going to make this box just a little bit larger so that we can actually have space to fit everything. All right, so we're going to make that just a little bit bigger to fit everything. All right, so let's start with the first. The first box here is going to be 6x times 4x to the third power. So I'd like to show my work on the side for this. And how do we multiply that? Well, we have to go back to our idea and understanding of exponent rules. We're going to multiply the 6 with the 4 and get 24. And then the x to the first power times x to the third power is going to be x to the fourth. If you're not sure how we got that, go back to the exponent rules videos that I made earlier, and you guys will definitely understand why we combined that to get x to the fourth. Now the second box is going to be, and I like to just go across, I'm going to multiply this negative 2 with the 4x to the third. So negative 2 times 4x to the third. And that is going to give me, well, 2 times negative 4 is negative 8. And then we're going to leave x to the third. We can't really multiply that because there's no other variables there. So this box will be negative 8x to the third power. And let's continue. We have 4 boxes, so we have 2 more to go. All right, so we're going to be multiplying 6x times negative 7. And here, of course, we're going to get a negative, oops, sorry, not a negative 2, a negative 42 x. Negative times a positive gives us a negative, so it's a negative 42 x. And the last box is going to be the negative 2 times negative 7. We just have 2 integers here, so we're going to multiply the negative 2 times the negative 7, and we're going to get a positive 14. And the way we get our final answer with a problem like multiplication is we add all the terms. So we add this with this and this and this. And if we look at these 4 terms, you notice that they all have different exponents. This has an exponent to the 4th power. This has an exponent to the 3rd power. This has an exponent to the 1st, and this one has no exponent at all. So we actually can't combine any of these, but what we can do is make sure that our final answer is in standard form. So I'm going to put my 24x to the 3rd power first, then my minus 8. Oh, I made another mistake. Sorry. That's x to the what? X to the 4th. Then it's negative 8x to the 3rd, and then we're going to subtract the 42x, and this is a positive 14, so we're going to do plus 14. Are our exponents lined up from highest to lowest? Yes, they are. So this would be our final answer. Cool. Let's go to our very, very last try. Okay. So now we have to basically be able to translate those words again. Remember the words product. When we see the word product, what operation do you usually think of? I hope it's multiplication, and if it is, you are absolutely correct. So we're going to be multiplying. Now we can see that the first polynomial here has how many terms? 3 terms. And then the second one has how many? 2 terms. Which means we are going to set up a 3 by 2 box. All right, let's set it up. It might be a little tricky, and I'm going to try and make it as large as possible so that it can fit everything. And we're going to just set it up. So let's put our first one, which is the x squared, the minus 2x, and then the positive 3. And then the next one is going to be the x plus 1. And let's begin multiplying. All right? X times the x squared, right, is going to be x to the 3rd power, and we can insert that into our box. Now, if we're continuing, we are going to do negative 2x, or let's do x times the negative 2x, and that's going to give us a negative 2x squared. Okie dokie. So far, so good. And x times the 3. And that's just going to give us 3x. Let us continue. What I like about the last one is that what's going on? We're multiplying everything by 1. Anything multiplied by 1 is always going to be equal to itself. So that gives us a pretty easy thing to go off of. And this is just going to be the x squared. This is going to be the minus 2. And this is going to be the plus 3. How do I do that so fast? Because each of these terms up here are just being multiplied by 1. So we know it's just going to be the same exact thing. The x squared minus 2x plus 3. Now we look for our like terms. Are there any like terms in here? Are there any? Well, we have our exponent 2. That's the same. And then we also have our exponent 1, which is the same. So let's go ahead and get our final answer. Our final answer is x to the 3rd. When we combine our negative 2x with that negative 2x squared with the 1x squared, we're going to get a negative x squared. When we subtract, when we combine the 3x with the negative 2x, we're going to end up with a positive 1x. And lastly, we'll have our plus 3. Are our exponents lined up from least to greatest? Yes, they are, which means this will be our final product for multiplication. Now let's look for our answer in the answer choices. Do we see it? Yes, we do. The answer is answer choice 1. Good job. Great job. All right, we're going to just end this off with a quick discussion. If we have Josiah, who is asked to subtract 3x squared plus 7x minus 10 from 10x squared minus 4x plus 2, and he wrote the following expression. Explain Josiah's error and correct it and continue to subtract. So what's going on here? He wrote the first minus the second. And the reason why this is incorrect is because we're subtracting from, keyword here is from, the 10x squared minus 4x plus 2. So that's actually the expression that we want to start with, instead of starting with the 3x squared plus 7x minus 10. So we're going to start with the second expression that's written. And actually, it's super important because subtraction is not commutative. So we actually have to be very careful with the order in which we place these expressions. And let's go back to subtraction. How do we subtract again? Over here, it tells us distribute that negative to all the terms, and then combine them. So let's keep on going. We're going to distribute that negative to the first term, to the second term, and to the third. And what do we get? We start with the 10x squared minus 4x plus 2. And now we're going to subtract the 3x squared. We're going to subtract the 7x. And we're subtracting a negative 10. We're subtracting a negative 10. So this will become a plus 10. And now we can combine our like terms. This term can combine with the negative 3x squared, and that's going to give us a 7x squared. We're going to combine the negative 4x with the negative 7x, and that's going to give us a negative 11, right? Two negatives when you are combining will be another negative. All right, and then lastly, what do we have? We have the 2 combined with the 10. And since they're both positive, it's just going to be a plus 12. Now, are our exponents lined up? Are they lined up from the highest to the greatest? The answer there is yes. So this will be our final answer. So were we able to evaluate these expressions and put our final answer into standard form? Take a moment to think about it. Do we know how to subtract expressions? Do we know how to multiply and evaluate them and get our final answer into our correct form? I think we have. Good job, guys. So, thank you so much for watching. I hope this video was helpful for you guys, and I'll see you all in the next lesson. Bye-bye.